नाजरीन, कश्मीर लाइफ के आज के शो में हम आज बात करेंगे यूनिवर्स के हवाले से। जैसा कि आप जानते हैं, रिसेंटली नासा ने जो नया टेलीस्कोप इंस्टॉल किया गया है स्पेस में, दैट इज सपोज्ड टू सक्सीड द हबल टेलीस्कोप आफ्टर मोर देन 30 years. इट इज द जेम्स वेब टेलीस्कोप। सो इस टेलीस्कोप ने जो खला में है, इसने काम करना शुरू किया और कुछ अमेजिंग फोटोग्राफ्स जमीन पे भेजे हैं कुछ तस्वीर। So these amazing photographs are in circulation. These are being talked in science community, in media, everywhere. So what is the essence of these photographs? How these will understand us in understanding the universe better? For that, we have today requested Professor S. Chatterjee. He has been a professor at the Indian Institute of Astrophysics in Bangalore. Professor Saab, welcome to the show.
Thank you, please. Thank you.
Professor Saab, we just wanted to understand that universe is too huge, it is too huge for a human mind. But how these small photographs of not more than 2,000 or 5,000 pixels will tell us about it, and how it will make us understand universe better.
Yes, as you understand that when we look at an object, we try to understand from its parts. So even though we are looking at a very small portion of the universe, but the part that we look, we consider it to be a very representative. और वो जो representative part है, अगर उसे हम समझ सके, तो we will get an enough evidence of how the universe exists, how it interacts within itself. ये सब हम समझ पाएंगे. Just as this, I'll give you a very simple example. See, it is in the year 1609 that Galileo used the telescope for the first time to look into the sky. So he looked into what we call the Milky Way. तो पहले लोगों को ये समझते थे कि Milky Way is nothing but just a smoke or some such thing. But with the help of the telescope, he could prove that it is full of stars. Okay, he saw only small part. लेकिन वो जो small part देखने के वजह से हमारे जो ध्यान में आता, जो हमें अपनी universe के about the universe, so that we try to extend, उससे हम model building करते हैं, and finally the very concept of galaxy came up, or there are different galaxies if that concept is not more than 100 years old. I'll come to that history. So you see, the science जो है, its journey is very long, but now as we progress more and more, तो इसका जो developments है and its progress is becoming faster and faster. So in a nutshell, I will just begin with this part. Let me wait for your next question or any other explanation you would need. Please.
No, but before we see what Hubble had done and what we anticipate and expect this James Webb to do in coming years, so a natural question for a layman like me is how much we actually know about the universe, of which we are even smaller than a dot.
We are smaller than a dot, but the dot is trying to understand the whole universe. Okay, we have the capacity. Let me tell you, science never understands through one shot. It is a progress. जैसे मैंने कहा कि लोगों को तो गैलेक्सी के बारे भी नहीं पता था, पहले ही जब गैलीलियो साहब ने यूज द टेलीस्कोप तभी हमें पता लगा कि ये जो है मिल्की वे, it is a galaxy full of stars. So about 100 years ago, it is very interesting. It is exactly 100 years ago. In astronomy, there was a debate और इसी को हम एस्ट्रोनॉमी में कहते हैं द ग्रेट डिबेट. It was a great debate between two very great astronomers, and their name was, one is Harlow Shapley and Herbert Curtis. So Shapley had said that all the objects that we see, they are in the Milky Way galaxy. Whereas Curtis had data to show that no, there are plenty of galaxies. So you see that debate, finally it proved that Curtis was correct. Ours is not the only galaxy, and we know today that there are millions and millions of galaxies. So at one step, we may not go a very much far, but that distance covered is very important. And I would say a great distance was covered by Hubble, and much greater distance will be covered by today by the James Webb in the future years. So in a nutshell, I will just summarize this part only. And I'll wait for any. Let us have a discussion, please. Yeah.
So basically, जो हमारी understanding है, see, we are still basically, I'm talking of the textbooks. Sciences are much ahead of the textbooks that are actually given to the students. But it took us a lot of time between electron and proton, many decades, and between getting in Pluto into the solar system and then elbowing out it from the solar system, it took a lot of time. So what are the new changes? New changes we anticipate, we expect the new discoveries and exploration will help us understand, will make happen in coming days.
Yes. So what this is going to help us is this. Now I will go back again. I will go back again 100 years ago, because we have to work with the help of perspective and comparisons. So when Harlow, Shapley, and Curtis were talking of the galaxies, so there was a man called Edwin Hubble. He used a 2-meter telescope to look at different galaxies, and through that he discovered that galaxies are moving far away from each other. Okay, this is called the redshift. They're moving far away from each other, and so that is why we call it is an expanding universe. Okay, now how do we measure the expansion of the universe? It is through what is called the redshift. We know that the major component of the universe is hydrogen. So hydrogen has a spectroscopic line, and since the stars or galaxies are moving away, it will be the wavelength of light increases and becomes redder and redder and redder. इसे हम कहते हैं Doppler shift. ये Doppler shift अगर, and what Hubble could show that farther away the galaxies are, faster they are moving. Okay, so this also gives us a measure to find out how far the different galaxies are. So this is one point. Now both Hubble and now with much bigger accuracy and detail, the James Webb telescope, which mainly operates in the red to infrared range, will be able to measure the redshift more accurately. That is one. And secondly, it will be able to measure and detect objects and measure their redshifts for very faint objects also, which otherwise Hubble could not see. This telescope will be able to see. So this is a big advance that we are going to get, and I'll tell you a little detail a little later if you want to know. Yeah, please.
So I was personally looking at the photographs, the comparison of photographs between the Hubble and the James Webb. In fact, Hubble operated for last 30 years, and James Webb started quite last week, actually dishing out what it captured. But it hasn't fundamentally changed the structures or the superstructures that it has captured. It is the diameter, it is the outer, how can I say that, by and large, it seems one is a brighter picture with lot of detail, and one is slightly painted one. So if we believe that all the galaxies, all the superstructures in the universe are changing, then why is the image constant with variation in
Yeah.
detail only?
Yes. Now let me tell two things. First of all, the capacity to detect by a telescope depends upon the diameter of the telescope, how big it is. So diameter of the Hubble was 2.5 meters, and this is 6.5 meters. So therefore, its light gathering capacity of this one is much bigger. So this is one. And moreover, it is operating in the infrared. That advantage I will come to. So it can detect fainter objects. But most important point is this: what it is going to look at in future, right? Hubble has looked at certain things. Now this is going to look back about 12 to 13 billion years back in great detail, and it will bring us the signal, say for example, of galaxy formation, how the galaxies were formed. So that there people have certain ideas, theoretical ideas, but we still do not have the evidence. Okay, now those are the kinds of objects, those are the kinds of details which are required, and that could not be satisfied by the Hubble. We anticipate that this telescope, because of its greater efficiency, will be able to do that for us. As a first, it doesn't mean that everywhere things will change, but in certain areas which we definitely need very accurate information, this will definitely give in a much greater detail and accuracy than the Hubble could give. Okay, that should be my answer. Yeah.
Professor, there is a very hypothetical kind of question. As I understand this measuring of the distances, we use light, and that is why we talk about light years away and all that. Since we are in technically, we are in a solar calendar on Earth, and we count on 365 days. Yeah, and which in light years it could be thousands of years, maybe 35,000, 37,000. My question is, since in 2002 with the help of James Webb, we are able to go back to many crore years away. Does that essentially mean that present and past exist at the same time?
Yeah. So yes, it is like this. You see, essentially everything depends upon our entire knowledge system depends upon the signal that I receive. Okay, I can see you because I know that you are present there, that Masood Hussain Sahab is present there because I'm getting the signal. Now we are at the present, but this is a telescope. By looking at the objects, and from there, it allows us to know about very, very distant past. So this is again a very interesting point. The sitting at the present, we always try to look at the past. Much of our human knowledge is also based on that. It is not in astronomy alone. Archaeology, history, all these. We have a curiosity to look in the past also. This is a human emotional issue perhaps, but here the science dictates that let us look at the past, how we came into being, how the universe, what happened to the universe before our solar system came, what happened, how was a galaxy formed, was the stars formed first and the galaxy formed, or the galaxy formed and from that the stars formed? I believe the second one is more likely. So ये सब सवाल हम पैदा हो रहा है हमारे साइंस की एरिया में, और ये सवाल हम तो पूछते रहते हैं, but unless we have an evidence, science cannot progress. And science always tries to look at the evidence. It is an evidence-based search. That is, I would say.
No, but that is basically, yes, I also, when I'm talking to learned men, wise men, scientists, they say they essentially need to have a good question so that
Yes,
they
please.
can have a better answer.
Correct.
But basically, this conversation is primarily driven by the photographs that are in circulation. So how
Yes.
can we actually now explain them? These are it's a set of 4 or 5 photographs. One,
Yes.
the caption of one read is that it is it is just a bit of grain of sand, of the
Yes.
sand. So
Yes.
that if explained, shows thousands of galaxies or universes. So the another one is showing the closest nebula that we have.
Yes. Yes.
In which it says that it shows some kind of star birth, and then we have a dying star phenomenon in that. So how can we this for a layman like me? How can these be
Yes.
explained?
See, this is all based on our certain understandings, which are based on our knowledge of science itself. Now, for example, uh, the question uh, about the nebulae. Okay. Now, the composition of the nebulae are very important. What they look like, how they are composed, because the amount of matter present in the universe is a very important, very crucial for every one of us. Star formation. The question of star formation is still an unexplained situation. The question is that how is a star formed? There is matter, matter collapses, okay, by gravitation. So it becomes more and more compact. But as it becomes more and more compact, it should give out radiation. Can the radiation escape throughout? And here, if it be surrounded by a dust cloud or a nebula, then the nebula will not allow the radiation to escape. Then the matter and radiation, then the object will get heated up more and more. So it is a very detailed interaction that takes place. Now, in order to understand all of them and to know really what was happening, we must look at all these kinds of objects, whether a nebula, whether there are star bursts, and many such objects we must. And it is only through these that a comprehensive understanding will come. See, there was a stage when we were very satisfied with the solar system itself. Okay, then we moved ahead. We started understanding about galaxies. A galaxy will have about 10 to the power 11 to 10 to the power 12 stars. So that is the scale. But this understanding is not possible unless science progresses. And once science progresses, question comes: this is what happens to galaxy. How was it formed? So you see, science is something which is a, what I would say, that never-ending quest. So today I may be satisfied with something, knowing the, say about a nebula, but while understanding the nebula, something else, some other question will come up. Okay, so this is the way science always progresses, and I think that is the beauty of science, and that is why science is so fascinating. And journalists like you have a great role to play in taking these kinds of message to our lay public. Science is universal. It doesn't distinguish whether I'm from India or somebody is from Pakistan or somebody is from Bangladesh. Universe is the same for every one of us. Okay, so I would say, therefore, this kind of dialogue which we are doing it today is going to serve a very important cause for every one of us.
Professor, every time we talk about make and break in universe, somehow directly or indirectly we go to the Big Bang.
Yes, yes.
But does science offer some kind of an answer to where actually did the Big Bang take place? Big Bang took place, it is okay. But where it happened?
See, where and why, the science will always say that how much we can go and how much we cannot go. So science puts its own limits to knowledge. Science
Yes.
never claims that we know everything. So this is the difference between science and there may be other branches of knowledge or other branches of human comprehension. And science always say that we should relate it to observation. See, to give a very simple example, when we were in school, in our chemistry practical, we used to divide our book or page into three parts: experiment, observation, inference. Okay. In science, experiment is very important. Now, in astronomy, you often cannot do an experiment. That we cannot say that give me two galaxies and I'll push them. But nature is doing her own experiments all the time. And we keep noting the observations. Now, as our capacity to observe goes deeper and deeper, our curiosity also goes deeper and deeper. Okay, so where it happened and what led to it, we still do not know. And this, let us accept, is the limitation of our knowledge. Okay, this is still our limitation of our knowledge, and science always accepts it. Yes, please. Yeah.
Professor Sabyasachi Chatterjee, before concluding this very informed conversation, I'm driven by my own quest to understand. Uh, Basically, black holes were in debate very recently, and parallel universes is some kind of a debate that never ends. Would you like to talk on these issues and how these help us understand the universe better?
Yes, I would not. I would just only comment on the black hole question because this is a very as a as a concept. Sometimes it becomes very obvious that we know that if the gravitational field be too high for any object around any massive object, as we know, when we talk of a spacecraft, we always talk of its escape velocity, isn't it? That unless you shoot the spacecraft with this minimum velocity, it cannot go out of the Earth's gravitational field. So, therefore, a question always came up that can we have objects for whose gravitational field you have to have escape velocity equal to the speed of light? Fine. Because if speed of light is the highest possible velocity that theory of relativity will give us, so in such a case, nothing can come out of it. Correct? This is an ordinary concept, but that it is more profound came up only with Einstein's theory of relativity. But then the question comes Einstein himself was puzzled that if such be so, then what happens? Everything collapses or what? See, even what we say that in science there is no ultimate human authority. Einstein got puzzled by what he himself had found. And maybe he was thinking it was wrong. But it took about 50 years later to show that according to theory of relativity, massive objects should collapse and form black holes. And this is where first theoretical, a very major, I won't say first, a very major theoretical contribution came from an Indian physicist. His name is A.K. Raichaudhuri. He was my teacher in my MSc class in Calcutta. Very, very inspiring teacher, very tough. But then his idea got further developed elsewhere in England, by Penrose and yeah, Penrose and Hawkins. And so the question of black hole came to a more, I would say, strong theoretical footing. And it was only last year, not last year, 2020, the Nobel Prize went for the discovery of supermassive black hole at the center of our galaxy. Because our galaxy is so dense So people started asking, what is the gravitational force that holds so much matter there? An answer was that perhaps there is a supermassive black hole. And it is only about 2 years ago the Nobel Prize went for the discovery of the supermassive black hole. So there is no question about the existence of a black hole. So evidence, so science is always evidence based. And about the black hole, mind you, it has taken about 100 years after Einstein's time to get the evidence. So things progress. Sometimes progresses are fast, sometimes it may be slow, but science doesn't move backwards. This is one thing. It does not move backwards. It always pushes you forward. Yeah.
So,
So
Professor Saab, it was very interesting conversation, and we hope to have more conversations in coming days. But I think we humans have our own limitations and our own very small calendars, and the universe thinks and reveals itself in light years, so it needs a lot of time to understand the
yeah, true.
enormity of the universe.
Thank you very much. We would
Thank you,
like
sir.
to
So great of you that
revisit. Thank you very much. Yeah.
you could spare so much of time for us. We are
Thank you.
really obliged, and we thank you.
Thank you, please.